Namaste learners, I am going to explain all about the electric dipole. The first topic is what is electric dipole? Electric dipole is an arrangement of two small charge equal and opposite in nature placed at a small distance. This is the electric dipole. Means electric dipole is a just like minus q, this one is the minus q, this one is the plus q. Okay, and the distance between these two small charge particles is very small, considered as 2a. Considered as 2a for simplicity. For simplicity of derivation, we consider a distance 2a. And electric dipole is the arrangement. Electric dipole is the arrangement of two equal and opposite charge. Electric dipole is an arrangement of two equal and opposite charge. Equal and opposite charge of a small amount placed at a small distance. A small distance is called electric dipole. And second thing is electric dipole moment. The second thing is electric dipole moment. This is P. This is a physical quantity. Electric dipole moment is a physical quantity, whereas electric dipole is an arrangement of two equal and opposite charge. And this physical quantity is the product of either charge and the distance between these two charges. Electric dipole moment is a vector quantity and it is just an arrangement. And vector quantity means the direction is from negative charge to positive charge. And so many times this question is asked, from negative charge to positive charge. That is, this is the electric dipole moment. Direction of electric dipole moment from negative to positive charge. And this is the vector for P vector equal to product of either charge. Electric dipole moment is the product of either charge and distance between them. Clear? Okay. Then one thing is here I want to discuss. What is the use of this polar electric dipole moment? Means, as you know, in chemistry there are so molecules are polar and non-polar. A polar molecule is those molecules which have net electric dipole moment. A polar molecule are those molecules which have net डायरेक्ट्रिक मोमेंट. मतलब अगर कोई मोलिक्यूल के पास नेट इलेक्ट्रिक डायपोल मोमेंट है तो वह पोलर मोलिक्यूल है, और नेट डायपोल मोमेंट नहीं है तो वह नॉन पोलर मोलिक्यूल है. जैसे एग्जांपल H2O, as you know, H2O. The structure of H2O is open book system, H and H, and the angle between these is 104 and 5 degree. This is the angle between the waves. And oxygen is just negative charge, partially negative charge, and this one is the partially positive charge, and this one is the partially positive charge. Then dipole is minus charge to plus charge, means this is the dipole, one dipole, and this is the other dipole. And net dipole is this. This is the net dipole. Means H2O is polar molecule. H2O is polar molecule because it has net electric dipole moment. And similarly, carbon dioxide, linear structure. This is the open book structure. Water has open book structure, and carbon dioxide is linear structure. Linear structure means C double bond O and double bond this also O. And here is negative charge. Oxygen partially negative charge. This one is the partially positive charge. Then dipole is negative to positive, means dipole means negative to positive. This one is also negative to positive, and both are equal in magnitude, opposite in direction and equal in magnitude. Opposite in direction and equal in magnitude. Hence net dipole is 0. Here net dipole is 0, here net dipole not equal to 0. Those molecules are polar which has net dipole moment, and a molecule which have net dipole moment 0. This is called non-polar. And this is called polar. Okay. Then this is introduction of electric dipole. Once again, electric dipole is an arrangement. Electric dipole moment is a physical quantity. It is a vector quantity. It means unit. What is the unit of this? Then unit is coulomb, and the distance in meter. Then it coulomb meter. And I always warn you should put a space between two units, because if you not using the space, then this is the centimeter and this is wrong. And that's why this one is capital letter, this one is small letter, this one is a small letter, this one is the capital letter. Then coulomb meter. Now electric field due to electric dipole. Electric field due to electric dipole. It has two cases. Case 1. This one is called axial. When a charge minus q is placed here, this is the plus q, and the distance between these two is 2a. And we have to find electric field at this point P. And as convention, we consider here 2a distance, and this is the point O, midpoint of dipole. O is the midpoint of dipole. This is midpoint of dipole. For our simplicity, I consider R distance from midpoint to P, where we want to find the electric field, and this is the point O. Then this is the distance from here, R plus A, and from this the distance is R minus A. Is it clear? You can see here the distance is A, this one is A, and this one is also A. This one is A, or the distance from here to here is R. Then this is R plus A, this one is R minus A. And as you know, we put a unit test charge at the point where we want to find the electric field. It is very clear. And suppose the name is A and B. The two charges name is A and B. The A charge attract towards in this direction EA, because this is the plus charge, this is the minus charge, attract to each other, and this one is repel to each other. This is the EB. Okay, just now write the EA, electric field due to charge A. EA means in this direction. Then K Q upon R plus A to the power whole square. And the second is EB, KQ upon R minus A square. R minus A square. This one is the R plus A square. And the electric field due to which charge is more. Then the number, the fraction, here is the fraction given, there is R plus 1, this number is more and this number is less. Then less number, denominator whose a fraction is less, whose denominator is less, means EB or simply R minus A is less than R plus A. That's why EB is greater than EA. Okay. Then net electric field at point P, net electric field at point P is EB minus EA. EB minus EA means this is, suppose x-axis, then electric field from O to X. Why? Because EB is greater, and that means KQ by R minus A whole square minus KQ by R plus A square. This becomes KQ is common, then 1 by R minus A whole square minus 1 by R plus A whole square. This one is equal to KQ. This one is R plus A to the power whole square minus R minus A to the power whole square by R minus A to the power whole square minus R, into R plus A whole square. This one. Okay. Then you just remove this. R square plus A square plus 2RA minus R square. Okay. R square minus A square plus 2RA simply, and A minus B whole square into A plus B whole square. What is the A square? A minus B, 2 minus A, just I am writing here simply R plus A whole square. This one is R square cancel, A square and A square cancel. Then electric field is equal to KQ, 2RA and 2RA, 4RA upon A minus B into A plus B. As you know formula, A plus B into A minus B equal to A square minus B square. Then this becomes A square minus B square whole square. A square, R square minus A square to the whole square. This is the net electric field. But the format is not right here. I want to correct the format of electric field. Just like electric field is equal to, as here electric field is equal to K. K means what? 1 by 4 pi epsilon naught. And Q into 2A. Q into 2A is P. Then here I am written here P. And remaining is 2R. So then 2P R upon R square minus A square to the power whole square. This one. This is the correct format of the electric field due to electric dipole in axial case. And you may think or write, if R is very greater than A, means A tends to 0. Then electric field becomes 1 upon 4 pi epsilon naught 2p by R cube. 2p by R cube. Just you think. And this format is mostly used. This format is R cube. Denominator is R cube. This format is used very much. Once again, electric field at point P is towards OX EB, opposite to OX EA, EB greater than EB. That's why just subtracting two things and we get 2p by R cube. Here A is 0. A is 0 means this one is 0. R square R4 and R cancel, then R cube. Due to point charge, electric field is charge is everywhere, don't worry. Electric field is inversely proportional to R square. Just you read about the rod, charge rod. There electric field is inversely proportional to R. And here dipole electric field is inversely proportional to R cube. Then the graph of this is, the shape is same, R, and this is the electric field. Shape is same, but the steepness of graph is different. For R cube, more steeper. This is the least steeper, and this is the less steeper. And you can draw easily. Now I am going to explain the electric field due to electric dipole in equatorial line. Equatorial line. Equatorial means, suppose this one is the minus charge, this one is the plus charge, and this is the center O. We have to find the electric field at this point. Then you must put a charge plus 1 at the point where you want to find the electric field, P. This is the point. Now you can draw the line for denoting the electric field this, because this one is the attraction force, plus and minus. This one is the attraction force, this one is the attraction, and this is the repulsive force, as like this. This is the repulsive force. This one is the repulsive force. Means if it is a EA B, then it becomes EA and this becomes EB. And I want to draw just equal length. Okay? Why? Because charge and distance both are same. That's why this and this vector are approximately equal. Okay? And that's why I am drawing here equal length. Okay? And this is the point. As you know, this is the distance A, this is the distance A, this is the distance R. And this distance means this one is the P. Then AP is R square plus A square whole root. And also BP is R square plus A square whole root. And as you know, electric field due to point charge KQ by R square. R square plus A square whole root. Then EA and EB both are equal in this case. And this is the theta and this is the theta. Just I consider. Then the angle becomes in this case exterior angle of these two angles. Then it becomes 2 theta. Okay, this is the exterior angle. EB or EA, the angle is 2 theta. Okay, and the resultant force is just like Coulomb law. Draw then electric field this and this, the resultant electric field is this is the net electric field. This is the net electric field. Net electric field means the resultant of E net, means resultant of EA and EB. This is the theta and theta, this one is 2 theta, and one thing is more here. If EA and EB are equal, then the resultant is, just you know, resultant is 2E, let 2E cos theta is what? 2 theta by 2. It becomes 2E cos theta. 2E cos theta. No problem. And the value of E is, this one is square, and the value of E is this. Then 2 into K cube upon R square plus A square. This one. Okay. And cos theta is base by hypotenuse. This one is the base, or this one is the hypotenuse, or this one is the hypotenuse, R square plus A square whole root. Then it becomes A by R square plus A square to the power 1 by 2. Then it becomes K 2 cube A. This is the P. This becomes P. R square plus A square 3 by 2. Then net electric field is equal to 1 upon 4 pi epsilon naught P by R square plus A square to the power 3 by 2. This one is electric field required. And in this case, just like E equal to, when R greater than A, then E is equal to, A becomes 0 and this becomes what? R cube. Then again 1 upon 4 pi epsilon naught P by R cube. This is the common format. And E axial equal to 1 by 4 pi epsilon naught 2 P by R cube, and here is equatorial, means 1 upon 4 pi epsilon naught 2 P by R cube. The very good relation here, E axial is equal to 2 times of equatorial. Just you see here, means 2 into equal to, just you multiply 2 into 1 upon 4 pi epsilon naught P by R cube, and this value is this equatorial, means 2 into equatorial. E axial equal to 2 into equatorial. This is the second case. And what is the direction? The main thing. Direction is, in this case, in axial case, direction is towards P vector, means towards electric dipole moment. And in case of equatorial, direction is opposite to P vector. This is the P vector. Just you think here. This is the P vector. Here is the P vector. Negative to positive, and electric field is in this direction. Electric field is in this direction. Net electric field in this direction. And P is either. Then both are opposite. And that is why I am writing here opposite to P vector. P vector के अपोजिट में इलेक्ट्रिक फील्ड होगा. मतलब इलेक्ट्रिक फील्ड दो केस में, एक हो गया इक्वेटोरियल केस, दूसरा हो गया आपका एक्सियल केस, एक तीसरा केस 3, एंड नेम इज आर्बिट्ररी पॉइंट. आर्बिट्ररी पॉइंट ये क्या होता है भाई? नाउ आई एम गोइंग टू derive the formula of electric field due to arbitrary point. Suppose this is the dipole minus q, or this one is the plus q, and the distance between these two is 2a, and this one is o. The distance is 2a. Here is a and here is a, and want to find the electric field at the point P. This is the angle theta, this is the point P, and for finding the electric field at a point we consider a unit positive charge at that point, and after putting the +1 charge we draw a line from one charge point to another charge point, and after vectorial sum we can find the value of electric field, net electric field. But it is more difficult to find the distance AP and BP. This distance is BP, this distance is AP, and both are different sides and different magnitude, and that's why it is very difficult to find the value of AP and BP. And for this I use another method to find the electric field due to this case. Suppose electric dipole is in this direction. This is the electric dipole moment, and I want to draw two axes. One axis is along in this way. In this way, one axis is in this way, and another axis is perpendicular to this, such like this, perpendicular, just this one, and perpendicular to this one, perpendicular direction, this one, and the angle between these two is 90 degree. This is the 90 degree, the angle between these two axes is 90 degree. And break P in two components. One component is P cos theta, and another component is P sin theta. Means P electric dipole moment breaks in two dipole moment. One is P cos theta and another is P sin theta. Okay, means P cos theta is also electric dipole moment. It is electric dipole moment or component of electric dipole moment. Component of electric dipole moment along OP. And P sin theta is also component of electric dipole moment. Along just O by, this is the O by, then it is O by, component along O by. I consider both P cos theta and P sin theta is independent electric dipole moment. Considered as, not it is true, but considered as an independent dipole. And due to this dipole, this small dipole, this point is axial. Then we use the formula of the 1/4 pi epsilon naught and 2p upon r cube. Then 2p upon r cube. This one is the r cube. R is the distance from this point to this point. And here is 2p cos theta. Why? Because in axial direction, the electric dipole moment is P cos theta, and that's why I am writing here P cos theta. And another thing is equatorial, and it is also 1/4 pi epsilon naught P by r cube, but I use here P sin theta by r cube. This is the axial, this is the equatorial, and as you know, the angle between axial and equatorial is 90 degree. And then the E net is equal to, as you know from the vector formula, E axial whole square plus E equatorial whole square whole root. Just I am writing this 1/4 pi epsilon naught 2p cos theta upon r cube to the power whole square plus 1/4 pi epsilon naught P sin theta by r cube to the power whole square and whole root, this one. and this is the square, just put out, then 1 upon 4 pi epsilon naught. I think RQ also, just put out, and it becomes 2p, means 4p square. Okay, p also you consider outside from this. Then this is the 4 cos theta, cos square theta plus sin square theta whole root. This is the net electric field. Actually, this is net electric field. This is the net electric field. Means net electric field is equal to 1 by 4 pi epsilon naught P by RQ. One trick here is, suppose this one is the 3 cos square theta plus cos square theta plus sin square theta whole root. Means this becomes 1. Then the easy format of this equation is 1 upon 4 pi epsilon naught P by RQ and 1 plus 3 cos square theta whole root. This is the final answer. And one thing is here, if theta is used 0 degree, okay, theta used 0 degree, then axial condition you will get. Axial condition 1 upon 4 pi epsilon naught and P by RQ, and this is cos 0. Cos 0 means 1, 3, 1, 4, then this becomes 2p. If theta is 90 degree, then this one is 90, this one is 0, and this becomes equal to 1 upon 4 pi epsilon naught P by RQ. Means in a single derivation, you derive all these 3 cases. Okay, but these 2 values came from the axial case and equatorial case. The second method is, if you calculate the value of this AP and BP by the cosine method or any other method, then AP and BP, put the value of AP and BP, or simply one derivation required for these all 3 cases. But it is little confused and more difficult. That's why I am not using here. But it is simple also, because if you just find the value of AP and BP, then in a single derivation you can derive all these things. Okay. One thing more, direction of this in this case. Direction of this case. In which direction net electric field lies, means the electric field dipole case, then this one is the axial case. This one is, and the equatorial is just opposite of this. Then the resultant electric field in this direction. Then what is the angle of this? Simple way, this is the equatorial electric field, this is the axial, because due to the axial dipole moment, this is the axial electric field and this is the electric field, but this is the net electric field. Then the direction of net electric field is tan alpha equal to simply y component and x component. Y component is 1 by 4 pi epsilon naught. Y component means this component, equatorial, 1 by 4 p sin theta by RQ into 4 pi epsilon naught RQ by p cos theta. This one cancel, this one cancel. This is the one thing is missing. Which is missing? Okay, 2p cos theta. Then tan alpha is equal to 1 by 2 tan theta. This value means alpha is equal to tan inverse 1 by 2 tan theta. This is the angle from x axis, from E axis. Electric dipole in uniform electric field. Electric dipole in uniform electric field. Uniform electric field means the space or region where electric field at each point is same, and non-uniform is not same. Okay, means at a given space or area, the electric field at every point is equal, a constant, and this is a, suppose this is uniform electric field. This is a representation of uniform electric field, but in meaning, in the sense is different. But here is technical some mistake here, but I consider here this is the uniform electric field and this is the electric dipole. One is the minus q charge and other is plus q charge. And as you know, the force formula is F equal to QE. If plus charge, then force and electric field in same direction, and minus charge, then force and electric field are opposite direction. Then in this case, the force is acted in this case, and in this case, force is acted as this. Both are equal and opposite. And I am drawing a perpendicular line, this line. Okay. This distance is from here to here. This is 2a. This distance is 2a, and this angle is theta. Then the component of this is 2a sin theta. Okay, and the line joining of two forces, perpendicular distance, means perpendicular distance between two lines of action is, this one is the perpendicular distance between two lines of action, and this is the 2a sin theta. As you know, how 2a sin theta? Just you know, sin theta is equal to perpendicular by hypotenuse. Perpendicular, suppose that a, b, and this is m, then perpendicular is bm. And hypotenuse is AB, and BM is suppose that BM and AB is 2A, then BM is equal to 2A sin theta. That's why I am writing here 2A sin theta. The perpendicular distance is 2A sin theta. And when two forces are equal and opposite, then torque created, means rotational effect created, rotational force. Torque is a rotational force. Then torque is the product of either force. Yeah, this is the rotational force, or simply known as torque. As you just read in class 11, this is the either force into, torque is either force into perpendicular distance between two line of action. This means either force is F and line of action is D, and if you write in vector form, then D cross F, and this is the torque. D is 2A sin theta in magnitude, and F is F. F is not F. F is, you may write QE. This one is. Then 2A QE is 2QA E sin theta, and 2QA is P, means tau is equal to PE sin theta. this one, PE sin theta. And also in vector form, this becomes P cross E. This is very good. Means electric dipole in uniform electric field. This is uniform electric field. The net force is 0 here, but torque is here. Net force means this force and this force equal and opposite, and net force is 0, but rotational effect shows tau equal to PE, means PE sin theta, the value. If theta depends upon theta is suppose tau equal to P cross E, P vector cross E vector, or in magnitude PE sin theta. If theta equal to 0 degree, means E vector and P vector both are parallel, means both are in same direction. Then sin 0 degree, then torque equal to 0, no torque. Okay. If theta is equal to 90 degree, then torque becomes maximum, means E vector is perpendicular to P vector, or P vector is perpendicular to E vector. Both are correct. Then torque is maximum, and this becomes PE. Okay. Then if theta is equal to 180 degree, then what happens? Then again torque is 0, means P vector and E vector are anti-parallel to each other, then tau is here also 0. Means parallel or anti-parallel. In these cases, sin theta becomes 0 and tau becomes 0 in these two cases. And in a 90 degree it is a maximum, and all in between gives some value of torque. Okay. The electric dipole in non-uniform electric field. Non-uniform electric field means there are two charges, one is here and other is here. The force is F1 and the force is F2. Here F1 and F2 are not in equal magnitude, Hence net force is not 0. In uniform electric field, net force 0, but here net force is not 0, means F net is not equal to 0. And torque is depends upon P vector cross E vector, and somewhere R also. E depends upon R, or in a ER. Suppose that this means depends upon the position where the electric dipole is placed. When it is placed as a parallel, electric field and momentum both are in same direction, then torque is 0, and opposite, then also torque is 0. And some other places torque has some value. Okay. Then in uniform electric field, net force is 0, electric field is acted. In non-uniform electric field, net force is not 0, but torque depends upon the position where it is placed or how it is placed. Okay. Thank you.